So this is actually 7, 8. All right. And so what we're going to do now is we're going to prove properties of quadrilaterals using coordinate geometry. And this is all a review of what you know makes a parallelogram or a rectangle, et cetera, et cetera. But what we have done is we've used those formulas, slope, distance, and midpoint, to figure out something about all of these sides. And so the idea is, in a parallelogram, you've got 5 different ways to prove it a parallelogram. One way is to get opposite sides parallel. And if you're trying to prove opposite sides parallel, well, you should recall that in terms of our formulas, if you have the same slopes, you know lines are parallel. So to find parallel lines, you're going to look for slopes. If you want to prove opposite sides congruent, if opposite sides are congruent, that means they've got the same length. And to find the same length, you would use the distance formula. And then you could also prove that one pair of opposite sides is both parallel and congruent, so you use one of each formula. You could prove that opposite angles are congruent, and then you could also prove that diagonals of a figure bisect each other. Well, proving opposite angles are congruent, there's not a formula that we can use, but we can do something with this one right here. If you want to prove diagonals bisect each other, well, if the diagonals bisect each other, then the diagonals must have the same midpoints. So if they've got the same midpoints, then you know they bisect each other. So in rectangles, you've got the same thing that you can possibly do. You can prove it's a parallelogram with one right angle. Well, if you're dealing with right angles, whoopsie, don't know how I did that. Let me get rid of that. Can I erase this? Let's see. If you are dealing with right angles, then you are actually looking also at slopes, but right angles mean that their slopes aren't the same. You're looking for negative reciprocal slopes. Okay. Prove that you've got congruent diagonals. That's the distance formula. Prove that it's equal angular. Equal angular means all sides are the same. That's also distance formula. So with a rhombus, if you prove that it's a parallelogram with 2 consecutive congruent sides, distance formula. If it's a parallelogram with perpendicular diagonals, the fact that it's perpendicular, just like right angles, those are going to be negative reciprocal slopes. Parallelogram with one diagonal that bisects the opposite angles, can't do anything with that one. Equilateral, all sides are the same, distance formula. Square, get it a rectangle with consecutive adjacent sides congruent, so you're getting a right angle, which is going to be your negative reciprocal slope, and you're getting congruent sides, which means distance, and then prove the quadrilateral rhombus with one right angle. So you can use any of these methods to prove any of these types of quadrilaterals, but you need to justify your answers with the math. So if we go to this first problem, it wants you to use coordinate geometry to show that drab is a parallelogram. Well, the first thing you need to do is you need to actually plot these points and then take a look at the figure. So we've got our x and our y axis here. If you plot the points, we've got D being at -4, 0. We've got R being at 6, 0.
We need a custodian to go to the commons.
You've got A.
Thank you very much.
Here's A, and then B is at -2, 5. So that's, wait, what is that? That's B, -2, 5. So then when you connect your dots, it sure looks like a parallelogram, but now we have to use coordinate geometry to prove it's a parallelogram. Well, there are a lot of ways to prove it's a parallelogram. My choice is going to be that I'm going to prove both pairs of opposite sides parallel. Okay, so what I'm going to do is drab is a parallelogram because it has 2 pairs of opposite sides parallel. And I'm going to put in parentheses same slopes. Now I actually have to do the math. So I'm going to get a clean sheet of paper here. So if I get a clean sheet of paper, and I know that D is -4, 0, R is 60, A is 85, and B is negative 2, 5. So the slopes that I'm going to be dealing with is I'm going to be looking for the slope from A to B, and I'm going to be looking for the slope from D to R. These guys should be the same. And then I'm looking for the slopes from B to D, and I'll be looking for the slopes from A to R, and they should be the same. So when I actually set up the math, when I go from A to B, I'm going from 5 minus 5 over 8 minus negative 2. This becomes plus positive. 0 over 10 equals 0. When I go from D to R, I'm going 0 minus 0, negative 4 minus 6. When I do the math here, 0 over negative 10 equals 0. Because I've got the same slopes, I know that AB is parallel to DR. Let me go from B to D. So B to D, 5 minus 0, negative 2 minus negative 4. This becomes 5 halves. A to R becomes 5 minus 0, 8 minus 6. This also becomes 5 halves. Same slopes, so I know that BD is parallel to AR. So we've now just shown through coordinate geometry that there are two pairs of opposite sides are parallel. And we also wrote that as an explanation back on this first page. DRAB is a parallelogram because it has two pairs of opposite sides parallel, same slopes. B wants you to find the length of the altitude from B to DR. Well, an altitude is just a perpendicular segment. So if I were to actually draw in my altitude, I can count it. I'm going to call this, I don't know, BX. I don't know. So altitude BX is going to, in this case, be 5 particular, or 5 units. And there's that answer. Okay. Let's take a look at the next one. So the coordinates of rhombus PQRS are P is 3, 1, Q is 2, 6, R we don't know, S is 4, 0. We've got to find the coordinates of R. So the idea is if we start plotting some of these things, we've got to plot negative 3, 1, which is P. Q is 2, 6. R we don't know, S is 4, 0. So the idea is we know we have a rhombus, which means all the sides have to be the same. So we know that if we were to connect 3 of the sides and it goes P, Q, R, S, I've got Q, R, and S right here, which means P has to be somewhere over here. So one of the ways to figure it out is to say, okay, well, if I've got a rhombus, I've got to have my opposite sides parallel. I'm going to do a quick counting of slope here. I'm going to go up and over, and I'm going to realize that my slope is up 1, 2, 3, 4, 5 over 1, 2, 3, 4, 5, which means in order to get that same exact slope, I need to locate point R by counting up and over from S, up 5 and over 5. So I'm going to count up 1, 2, 3, 4, 5 over 1, 2, 3, 4, 5. And right here is where I should be locating point R, because my slope should be the same. And this ordered pair should be 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 4, 5. And that means R is coordinates of 9, 5. I don't know why that's not coming out for me. So 9, 5. Okay. So we've got R now. There we go. And now we need to show by means of coordinate geometry that PQ and PS are congruent. PQ and PS are just two sides. So for sides, then what I have to do is a distance formula. So I'm going to come on to a new page. So this is B. I need to show that PQ is equal to PS. And I'm going to use the distance formula. So PQ is going to be negative 3 minus 2 squared, and then it's going to be plus 1 minus 6 squared. And so what happens here is I'm going to get the square root of 25 plus 25. So PQ is square root of 50. I could leave it like this if I wanted to, or there's no reason to break it into 5 rad 2. Either one is fine. Now I've got to get PS. And PS is going to be negative 3 minus 4 squared plus 1 minus 0 squared. And this turns into radical or 7 squared, which is 49 plus 1. And this is root 50 as well, which again, feel free to simplify, but you don't. So right now we know that PQ is congruent to PS. That was B. C says it wants you to show by means of coordinate geometry that the diagonals are perpendicular to one another. So if we're dealing with diagonals, and the diagonals here being from P to R, this is P. So from P to R and Q to S, we want right angles here. So if we can show that we've got right angles or negative reciprocals from those 2 points, from those 2 lines, then we are good. So I'm going to do a new sheet again. So for C, we're going to be dealing with slopes, and we're looking for negative reciprocals. And those slopes are going from P to R, and then they're going from Q to S. So from P to R, I'm going to have, in this case, P becomes 1 minus 5, and then on the bottom becomes negative 3 minus 9, which is negative 4 over negative 12, and this simplifies to 1/3. And then Q to S is 6 minus 0 over 2 minus 4, which means QS 6 over negative 2, which becomes negative 3 over 1. And these are negative reciprocals, so PR is in fact perpendicular to QS. And then we've got negative reciprocals. Okay, so that takes care of that. Let's take a look at the last one to do. Last one, we're looking to see that ABCD is a rectangle. So lots of ways to deal with a rectangle. So let's actually plot these points. And if you plot them, A is 4, negative 2. 1, 2, 3, 4. And then B is negative 1, negative 2. And then C is negative 1, negative 8. And then D is 4, negative 8. So the question, is this thing a rectangle? Well, in order to be a rectangle, you have to be a parallelogram first. So if I can get a parallelogram with one right angle, all is good. So I'm going to get a parallelogram by proving opposite sides are, I guess I'll prove opposite sides to be parallel. So let me go to a clean sheet. So I'm looking for prove opposite sides parallel by slope. So what's going to happen here is I'm going to go slope of AB is negative 2 minus negative 2 over 4 minus negative 1, which equals 0 over 5, which equals 0. I'm going to go for DC, which is negative 8 minus negative 8 over 4 minus negative 1, 0 over 5, which is 0. Well, that's the same. BC is going to be negative 2 minus negative 8 over negative 1 minus negative 1, which is going to be 6 over 0, which is undefined. And then I'm going to go for AD, which is negative 2 minus negative 8 over 4 minus 4, 6 over 0, which is also undefined. I'm doing empty set, but maybe we do undefined. So right now we know that ABCD is a parallelogram, is a p-gram, because AB is parallel to DC and BC is parallel to AD. We've got that part. Now we have to get one right angle, and one right angle is to prove that you've got a pair of negative reciprocal slopes. So I'm going to go back into my picture, and I'm going to go for, I guess, down here. I want to prove that this guy right here, that BC is perpendicular to CD by slope. So BC and CD, get a new page. Oh, BC, actually we already have the slopes at this point, because BC, we know the slope was undefined. And then we also know that CD, the slope is 0. So as it turns out, undefined and 0 are negative reciprocals. So then BC is perpendicular to CD. So therefore, ABCD is a rectangle, because two pairs of parallel sides and one right angle. Okay? So that's it. It's a lot to do. It's a lot of work. So you don't get a lot of these things to do, but the idea is slope, distance, and midpoint can get you all the stuff you need. All right, so good luck on the homework.